Okay, so the problem that we want to look at today is a circular motion style problem. So what we want to think about is we want to pretend that we have our car, and our car is driving at some speed, and we have to take a turn, and let's say our turn is, the turn has a curvature roughly of, let's say, 50 meters, and we're driving in our car that has a mass of 1,000 kilograms, and we're going to roughly estimate that the friction between the tires and the road is 0.5, the coefficient of friction. And what we want to know is, at what speed can we safely take our turn? So when we're driving around a turn and we're looking at the back end view of our car has some forces acting on it, normal force up, gravity down, and it turns out that the frictional force is what's holding us in and supplying the centripetal force to allow us to take that turn. So we know that the frictional force is just mu times the normal. So if we want to look at how fast we can go, we should first sum the forces in the y, and the forces in the y equal MAY, but we know that AY is equal to 0. So when we sum our two forces, we get the force normal minus force gravity equals 0, or that the normal force is equal to the force of gravity is equal to mg. And in this case, the normal force is just 1,000 times 9.8, and this turns out to be 98,000 newtons. 9,800 newtons. So we have our normal force of 9,800 newtons, and we now want to look at how fast we can go around this turn. So if we're calling this the y, what we would normally think of as the x is actually our radial. It points inward. The frictional force is going to point inwards towards the center of the curvature at all times. So when we sum the forces in the radial direction, we get MAR. And what we can do is, we know in the radial direction we only have one force, the force of friction, and so that has to equal MAR. And we've said before that AR is V squared over R. So the force of friction has to equal mv squared over R. So when we look at the force of friction is mu times the normal, which is 0.5 times our 9,800 from the normal. So the frictional force is then going to be 4,900 newtons. So we have our frictional force of 4,900 newtons. So we put our 4,900 newtons in here. We plug in our mass of 1,000 kilograms. We're solving for v squared, so we know the speed we're allowed to take. And we plug in our radius of the turn of 50 meters. So we get roughly 4,900 divided by 1,000 is 4.9. We multiply that by the 50, and that gives us our v squared. So this is roughly equal to 250. So v squared is equal to 250. And the square root of 250 is between about 15 and 16, so v should be about 15.5 meters per second. So if we wanted to take our turn safely, we need to take it at roughly 15.5 meters per second around our turn. If we're going faster than that, the friction won't be able to supply enough centripetal force to hold us on our curve, and we would slide out.